But this time we're going to be changing the slope. Last time we only worked with horizontal and vertical shift. Today we're still going to be using horizontal and vertical shift, but we're also going to change the slope. So our goal today is to be able to identify a few more things. We're going to learn how to identify the axis of symmetry, the domain and the range, and we're going to learn how to change the slope using A. So we're still working in vertex form. Kevin. No.
Kevin.
Yeah,
Nice
really.
job.
I still don't want you to be sleeping. Keep your head off your desk.
Are you looking? Sean,
Please don't write down yet.
I wasn't going to do the whole thing. So we're still working with our vertex form. Y equals A, parentheses, x minus h squared plus k. That's the form we're focusing on today. Next time we'll talk about standard form. So in vertex form, we talked about during the homework that this is our horizontal shift, K is our vertical shift, and the signs each told us a direction to go in. Our horizontal shift, when we were positive, it actually meant go left. Oh, that's my left. Left. Negative, go right. And vertical shift, we learned if it was positive, we go up. Negative, we go down. Yes.
What's that saying? Axis of what?
Axis of symmetry.
What's after the M?
S-Y-M-M-E-T-R-Y.
Oh.
And then A is going to change our slope.
can I go back? I can't see from here.
No.
Not like hard to see, but it's hard to like. Yeah. No. And that
So-
distracts me.
Our goal is to be focusing on what does A do to our graph. We've already learned what horizontal shift does and vertical shift does. It's positive, we go left, negative, we go right, or positive, we go up, negative, we go down.
What if do problems like x, y, z, freaking plus k equals 10 problems? They're so hard.
Because they're the beginning of where math can actually be useful in the real world.
Just kidding.
If you enjoy things like your cell phone, then hopefully someone knows how to do this because they need to know how to use math. So, what was our normal slope pattern? What did we usually use when we were graphing a quadratic?
Half of this doesn't make sense. Like that word. I know.
I'm happy to help you and talk to you individually after class right now. I'm trying to get through the notes because if I stop to pause and help just you, I'm going to lose everyone else and we'll go back to everyone talking, which will make me angry again.
Where are you from?
Yeah. So, when we get to the homework, I will come help you individually figure out what is confusing you.
I think the same problem.
Okay, what is our normal slope pattern? What did we usually use to graph a quadratic?
X and y.
Okay. We did make a table once, but I'm talking about the something over something, something over something. Aaron.
1 over 1, 4 over 2.
1 over 1, 4 over 2. That's our normal slope pattern. We figured that out using a table. But now it's something we should have memorized. 1 over 1, 4 over 2. That can change. We're going to find a new slope pattern if there's something in front of our parentheses. Most of our problems, either this was blank or it was negative on the homework. Now we're going to start putting numbers here, and that's going to change how we graph. So our new slope pattern, we're going to multiply the number in front of everything, a, by the top of our slope pattern. It only is going to change that top number. It only changes how far we rise. It doesn't change how far we run. We're always going to go over 1 and over 2. Always. That will never change.
Will we have to simplify it?
No. I mean, well, so we are not treating these as fractions, they're patterns. So if I get like 8 over 2, that's not the same as 4. We have to keep it as 8 over 2. So now that we can find our new slope pattern, we can graph any quadratic in vertex form. So we're going to be naming a few more things when we do this. The slope pattern, what it's going to do is it's going to change the shape of our quadratic. So normally our quadratic looks like this.
Good job.
Yes. That's our basic one. What that A is going to do is it's either going to stretch our graph up. It's going to make it skinnier. That's called a stretch. Or it's going to flatten our graph out, and that's called a shrink.
You have to draw that too. That's like
Yes.
60 different lines in one line.
You'll be okay.
But I'm gonna get confused.
Then draw them on 3 separate graphs.
I'm trying to make that work.
So, how we know whether we have stretched our graph up or we've shrunk our graph down is determined by that letter A. If A is bigger than 1, it's a stretch. So if A is an integer, even if it's a -2, we're just looking at the actual number itself. So 2 is bigger than 1, it's a stretch. If A is a fraction, it's a shrink. And if A is 1 or -1, then we didn't do anything at all. It's neither a stretch or a shrink. Stop bothering Andrew.
I'm gonna be taking.
I can lend you one. You got one? Okay. So if A is a fraction, then it's a shrink. And if A equals 1 or -1, then it's neither a stretch or a shrink. We left it like we do normally. Taylor.
Sorry.
So there's our possibilities. Stretch, shrink, or neither. And then we will have to change the slope sometimes now. So let's do an example now. We're going to have to name a lot of things. There's a lot you can learn from a graph. So we have a list of things we have to name before we can graph. We have a list of things we can name after we graph. Lacey, please be quiet. So the things we have to name before we can graph are information we need in order to actually draw the graph. The things we name after we graph is the list of information we can actually get from from the picture that we have graphed. So some of them we've already been labeling in our previous assignment. But now we're going to be adding a few more. So before we can graph, we need horizontal shift, vertical shift, we need slope, we need to know if we flip, and now we need to know if we stretch, shrink, or neither. So this is all the information we need before we can actually draw the graph itself. Yes, sorry, stretch, shrink, or neither. So horizontal and vertical shift, we practiced on the last assignment. We always do it the same way. Horizontal shift is the number inside the parentheses. So, horizontal shift. Autumn, what is our horizontal shift if it's the number inside the parentheses? What number is inside the parentheses? 1. Okay, so our horizontal shift is 1. We just have to determine, are we going to the left or to the right? So if it's negative, let's take a vote. Does negative mean to go to the left or to the right? Actually point in a direction. So I want everyone to be pointing whatever direction they think we should be going if it's negative. To the left or to the right? Okay? Okay? To the right. Most of you guys got it. Okay, why is it to the right? What have we said about the number? It's opposite of what we expect.
It's opposite of left. You.
So we go to the right 1. So vertical shift is the number outside, behind. So outside the parentheses and on the very far right. So William, what's our vertical shift? What number is outside the parentheses to the far right?
6.
Okay, there's 2 that's the exponent, but we do not use the exponents except to know that it is a quadratic. So yes, that is outside the parentheses to the right. Liam.
1.
Okay, 1 is usually our good invisible number, but I think I heard Taylor earlier and Dylan now. This time we use 0. This time it's an invisible 0. Okay, so our vertical shift is 0. If there is nothing written there at all, it's 0.
You have a listener. Oh, I already asked you that.
So if our parentheses are not there, then we have no horizontal shift. If there's no number behind the parentheses, we have no vertical shift. Now slope, this is where we have new information. Horizontal and vertical shift, we did the same way as last time. Slope, every time before was 1 over 1, 4 over 2. But now I have to change the slope because I have this number in front, 2. 2 is going to multiply by my old slope pattern to give me a new slope. So my new slope would be 2 over 1, 8 over 2. Again, these are not like fractions. We do not reduce. We just use 2 over 1, 8 over 2. So I crossed out the other stuff because we don't need it anymore. I used the old slope to find my new slope, but I don't use it anymore. So flip is the same as last time as well. If there's a negative in front of everything, yes, we have a flip. If there's not a negative in front of everything, we don't flip. So Lisbeth, do we have a flip or not?
I bet $5
No.
you flip. Oh. Oh, you gotta go with them.
Michael, please be quiet. Lacey, Taylor, please be quiet. So then we have to say whether we have a stretch, a shrink, or neither. Again, that's determined by this number out front. Is this number bigger than 1? Yes. So it is a stretch.
It's a stretch, guys. It's a stretch.
If that number was a fraction, it'd be a shrink. If there was no number here, it's neither because that's our invisible 1. Or if it's a negative 1, it's also neither. Yes, they are both here.
Thank you.
Hey, do you have to check me?
What is that?
Do you have to check me?
I guess.
Are you serious?
No.
No, it's me and
So now we draw our graph. I can't label the rest of my information until I draw the graph. You know what I realized? I need to skew this more. We're going to need a lot going up, so I'm actually going to put my line down here.
I see this on, what's it called? YPP.
Yearly personal progress, or
YPP. No, I see it on YPP, it's so hard, I don't even do the problem, it's just stupid.
we're still doing notes. I know we had an interruption, but I still need you to quiet down for the rest of notes, please. So we've drawn our coordinate system. We need to actually draw the picture of our graph now. Before we can do any of the after stuff, we need a picture. So we start with our horizontal and vertical shift. Horizontal shift is right 1. So from center I go right 1. Vertical shift was 0, so I don't move up or down. I just put my vertex there. Remember that first point we graphed, that's the vertex. That's kind of where all the rest of our points come from. So now I do my slope. My slope said go up 2 over 1. We have to repeat it on both sides because we know a quadratic is symmetric. It repeats on both sides. Then we do up 8 over 2. So from the center we go up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2. Up 8 left 1, 2. And now we can draw the picture of our quadratic. Remember, this is called a parabola. The picture of a quadratic is called a parabola. So now we can name all of the things after we've graphed. So our first thing we name is vertex. That's, again, something we did last time. Only adding a few new concepts, but it is a lot altogether. So vertex is this point here. So what is the actual coordinate of that vertex? 1, 0. We have to have both an x and a y. So we've named the vertex. So second, we named whether that vertex was a max or a min. Again, this is not new information from last time so far, on our after list at least. Is that vertex at the bottom of the graph or the top of the graph? Bottom. It's at the bottom of the graph. It's the lowest point on that graph, so it's a minimum. Yes. Yes. So now there are 3 new things that I'm going to ask you to name on the after portion. The first is called the axis of symmetry. It's the line we could fold our parabola in half and have those 2 sides touch. So this is called the axis of symmetry. That vertical line that we could fold our parabola in half and have the 2 sides meet is called the axis of symmetry. This is new information we have not seen before. So when I label it AOS, I just label it that instead of having you write out the words axis of symmetry because that will give you less to write. Just like horizontal shift and vertical shift, just to give us less to write. So we want to actually name that vertical line. So we have to think back to last year when we were talking about lines. Most of the time last year when we drew a line, we used the equation y equals mx plus b. but a vertical line was the only different type of line. Instead of starting with y equals, what should we start with to draw a vertical line? X equals. So, what x coordinate does this line go through? 1, which also happens to be the x coordinate of our vertex. And that's always going to be the case. This 1 is always used as what our axis of symmetry equals. So our axis of symmetry is the line x equals 1. So again, that's a new piece. A second new piece that we're going to name after is called the domain. We're going to name domain and range. But we need to define them first before we can name them. So I'm going to scroll down and then we'll go back up in a second. Domain of a function is all our x values. Basically, we look at the graph from left to right. So domain is all of our x values, which makes range all of our y values. This we're considering up to down. Considering how far up does our graph go, how far down does our graph go. So domain is how far left does our graph go, how far right does our graph go. Range is how far up does our graph go, how far down does our graph go.
You go back up for a second.
We're going to go back and up in 1 second. I'm going to have everyone write this down first, but we need to still actually name the domain and range on this example. So does everyone have this written down?
No, give me a second, please.
Okay.
Is this still count as racist? You're black, can you say that?
I think so, but
But I'm black.
What? I'm black.
I'm black. My mom's black.
Okay,
Okay.
thank you.
My dad's black.
My mom's white. I'm white.
so looking at this graph, we still need to name the domain and the range. So looking at our picture, we said domain is how far left do we go, how far right do we go. So following our graph, I'm going to follow our graph and keep going left. The arrows say keep going, so as I keep going, how far left would I go?
Oh, you can't go anymore?
I'd go forever. If I could keep drawing forever, I would keep drawing forever. How about when I go along my graph and go to the right?
Forever.
Also forever.
It's pie.
Okay.
It's forever.
Good guess. Okay, so we went left forever and right forever, which means we cover every single value for x. We call that all real numbers. And again, we have a math symbol for it. This one, so most of mine is shorthand just to make you write less. This is an actual math symbol that real mathematicians use. This stands for all real numbers. It says, we included everything. Ran out of room. Okay. Now, the y values are going to be different. Y values, we don't include everything. If I follow my graph, how far up do I go? Infinity. But then what happens when I go down? The lowest point I hit is 0 as I go down. So we need a way to write that out. I want everything above 0. So when we write range, we always start with the letter y. You could do infinity, or 0 to positive infinity, because we went up. But I was going to do a different kind of notation today. Technically, you could do this notation, but that's a whole another topic, so I wasn't going to include that today since we're already adding a lot. Okay. So we start with the letter y, and then we decide between greater than or less than. It's one of the two, greater than or equal to, or less than or equal to. Is our graph going up or down? Up. Our graph is going up. So which one would we use? Greater than or less than? Which one means go up? Greater than. So between those two choices, we decided on greater than or equal to. And then we said, well, the lowest point is 0. Again, we match one of the vertex values. This 0 is always used to help us determine our range. So that y-coordinate is always used to help us determine our range. So we're going to do just one more example. This time it's not going to be, this one is kind of half notes, half example. This next example, we're just going to show all the work you would show on the assignment. Does everyone have this down before I go to the next page? So our last example. Y equals negative 1/2 x plus 2 squared plus 4. Again, we have a list of things we need to name before we can even graph our function, and a list of things we can name after we've seen the picture of our function. So our before list, and you will have to write this in. You don't necessarily have to write the word before, but you will have to write the list in.
We have to draw the graph.
You do have to draw the graph. It doesn't have to have, I mean, you can just do the black arrows. So that's all the information we need to name before we can graph. So first we have to name our horizontal shift, which is again the number inside the parentheses. So Darius, what's my horizontal shift? What's the number inside the parentheses?
2.
2. Now again, we have to decide what direction is that telling us to go. If it's a positive 2, we are going in the opposite direction of what we expect, so we're going to the left. No, my left. To the left. I just have to think hard since I'm backwards from you guys. To the left, 2. Now we need vertical shift. Vertical shift was the number to the far right, outside of my parentheses, that was not an exponent. So Kamal, what's my vertical shift? Number to the far right.
Why did you put the left on before?
Sorry. And then Kamal answered what the vertical shift was. 4. Positive means we go up 4. So now we have to determine our new slope. We still always start with our old slope, 1 over 1, 4 over 2. And then what number am I going to multiply just the top of our slopes by? Negative 1/2. Again, these are not fractions, so we're not going to simplify them like fractions. We're going to actually end up with what looks like a fraction over a fraction. So negative 1/2 times 1 is still negative 1/2, but the bottom number should never change. The bottom number is still 1. Then we multiply negative 1/2 times 4, which is negative 2. The bottom number 2 should never change. I think on the assignment there's only 2 fraction ones. I know they're a little bit weird. It's weird to see that negative 1/2 over 1. So then flip is determined by if we have a negative out front. Do we flip? Yes. And we have to decide if it's a stretch, shrink, or neither. Shrink because it's a fraction. So now we can actually draw our graph. So starting from the center, we go left 2, up 4. There's our vertex point. Then we use our new slope. We don't care about this old stuff anymore. We care about the new stuff. We're going down a half over 1. If I'm going down a half, I don't even make it to the next line. I go halfway between. Down a half over 1, but we do still have to repeat on both sides. I go down a half, right 1. Then I go back to the vertex, go down 1/2, left 1. We know that because we saw the picture of a parabola, repeats on both sides. Then we go do the next one, -2 over 2. So now we go down 2 over 2. Down 2, left 2. Make sure to draw it as a U shape, not a V shape. So we've done all of our before stuff. Now we need to do our after stuff. And this is all part of before. We have some. So after stuff, I wanted you to name the actual coordinate of the vertex. What's the coordinate of my vertex?
-4.
Negative
+4.
2, positive 4. We need to include both. So positive 4 was the y direction, but we always go x direction first. So -2, up 4. So -2, comma 4. Is it a max or a min? Is it the top of the graph or at the bottom? Top, so it's a max. And write the rest down here, I just didn't have any room. We had to name axis of symmetry, and we have to also draw it in. Axis of symmetry is that vertical line where we could fold our quadratic in half. So it always starts x equals. And then what did we say we use every time? The x value of the vertex. So -2. Now I'll give you a hint on this. Domain of these parabolas is always the same. We always have arrows either going this way or this way. So we always go to the left and to the right, no matter whether we're pointing up or down. It's not true for every function, but right now we're just working with quadratics. So what was domain last time?
0.
All real numbers. Same thing this time. Still, all real numbers. You can get that answer for every single problem now. You should be able to say domain on every single quadratic I have you draw. Because it's always all real numbers. And then our last one was range. We started with y. We had to decide between less than or greater than. Is our graph going up or down? Down. So we use less than. And then we always use the y coordinate of the vertex. 4.
What about the AOS? What's the
AOS is this x equals -2. I just didn't think I could fit it in to the right.
Okay.